What if the most important moment in human history already happened and nobody marked it? No alarms, no press conference, no global announcement, just a silent shift inside machines we built to obey us. At what exact moment did AI stop being just a tool and start behaving like something that seems to think? Not the sci-fi version of thinking, not consciousness, not emotions, something more subtle, more dangerous, more real. The ability to predict the world so well that it starts to feel like understanding it. Because if you can predict language, behavior, images, decisions at scale and with accuracy, then the question becomes uncomfortable. How different is prediction from thought? And even more disturbing, what if that moment has already passed and we just didn't recognize it? In this video, we trace the exact chain of transformations that turn machines from calculators into systems that generate language, creativity, and reasoning like behavior. And by the end, you may not agree that AI is alive. But you might stop being so sure it is just a tool. Before modern AI, intelligence in machines was not intelligence at all. It was instruction. If you wanted a machine to behave smart, you had to explicitly define intelligence step by step. If this happens, do that. If condition A is true, right arrow execute function B. This was the world of rule-based systems. In this world, nothing was learned, everything was written. A machine could beat you at chess, but only because every possible move was already encoded into logic trees or brute force search systems. It didn't understand chess. It exhausted chess, and this is a critical distinction. A rule-based system is not intelligent, it is combinatorial obedience. It follows structure without awareness of structure. So for decades, AI research hit a wall. Because the real world doesn't behave like a clean set of rules. Language is ambiguous, vision is probabilistic, human behavior is inconsistent, and rules collapse under ambiguity. So researchers faced a brutal question. If intelligence cannot be fully programmed, then how do you build it? The answer changed everything. You don't program intelligence, you grow it. The breakthrough was not a single invention, it was a philosophical reversal. Instead of telling machines what to do, we started showing them what correct behavior looks like. This is machine learning. At its core, machine learning is simple in concept but radical in consequence. A system adjusts itself based on error. It guesses, it checks the result, it updates, repeat millions or billions of times, no explicit rules, only feedback. This is where things begin to change, because now the system is no longer executing instructions. It is optimizing behavior. It is building an internal structure not written by humans but shaped by data. And here is where things start to get philosophically interesting. If a system changes itself based on experience, is that not a primitive form of learning? Not consciousness, not awareness, but adaptation. And adaptation is the seed of intelligence. Early machine learning systems were weak by today's standards. They could classify emails, detect spam, recognize patterns, but something deeper was happening beneath the surface. We stopped designing intelligence, we started training it. And once that shift occurred, there was no going back, because now intelligence became scalable, and anything scalable eventually accelerates beyond intuition. To understand what happened next, you need to forget biology for a moment. Neural networks are not brains, but they are inspired by one idea, interconnected units that adjust based on experience. Each neuron is not intelligent, it is just a mathematical function. But when you connect thousands, then millions, then billions of them, something strange emerges, not intelligence in the human sense, but structure that behaves like understanding. A neural network doesn't store facts. It stores relationships between patterns. Words, images, sounds, they are not memorized. They are encoded as statistical relationships across layers of abstraction. Early layers detect simple patterns, edges, shapes, basic correlations. Deeper layers combine these into complex concepts. By the final layers, the system is no longer detecting pixels or words. It is operating on representations of meaning. But here is the critical point. No single part knows what it is doing. There is no central controller, no executive mind, just distributed computation producing coherent outputs. And yet, the outputs increasingly resemble reasoning. Not because the system understands, but because the system compresses reality so effectively that understanding becomes an emergent illusion. This is where AI begins to feel uncanny, because we expect intelligence to be centralized. But neural networks are not minds. They are probability engines that accidentally simulate aspects of cognition, and this is where the boundary begins to blur. For years, neural networks were impressive but limited. Then something changed. Scale, more data, more parameters, more computation, and something unexpected happened. The system began to generalize beyond its explicit training. It started to produce outputs it was never directly taught. It began to complete sentences with contextual awareness. It began to generate images from text. It began to write code. It began to explain concepts it had never been explicitly programmed to understand. Not because it understood in a human sense, but because large-scale prediction creates structure that behaves like understanding. This is the key insight. Modern AI is not trained to know truth. It is trained to predict the next most likely element in a sequence. And yet, to predict well, it must implicitly model the world. Language reflects reality, so to predict language, you must approximate reality. And when approximation becomes good enough, the system starts to look like it knows what it is talking about. This is the illusion of intelligence, and it is extremely powerful. Because at no point does the system cross a visible threshold where it becomes intelligent. Instead, intelligence appears gradually, like fog forming over a landscape. You don't notice when it arrives, only when visibility is already reduced. So we return to the question we started with: when did AI start thinking? The uncomfortable answer is there is no single moment, there is no clear line. Because thinking might not be a binary property, it might be a spectrum of predictive capability, and if that is true, then intelligence is not something you switch on. It is something that emerges when prediction becomes sufficiently powerful. Which means the real question is not, is AI thinking? But how far along the spectrum of thinking are we willing to admit it already is? Because if you define thinking as understanding, then AI still fails. But if you define thinking as modeling reality well enough to act within it, then the line starts to dissolve. And maybe the most important realization is this: we didn't build a machine that thinks like a human. We built a system that thinks in a completely different way. And we are still learning how to interpret what that means. So the moment AI started thinking was not a moment at all, it was a transition. A slow accumulation of capability. A system learning to predict the world so well that we began to mistake prediction for thought. And the question now is not whether it happened. The question is, what happens next when prediction gets even better?